All right, ladies and gentlemen, this is a quick look at series circuits versus parallel circuits and how we determine the total resistance. Your book refers to it as the equivalent resistance of a particular circuit. Um, Series circuits are super duper easy. Okay, the math is the sum of whatever the different resistors are. That is your total resistance. So if we look at this guy right here, again, I've drawn a quick little schematic diagram. I've got a 12-volt battery, and I've got three resistors that are acting in that circuit. And so if I were to try and determine what is the total resistance or the equivalent resistance of that circuit, I just take resistance 1, resistance 2, resistance 3, and I add them all together. Now, I put this dot here because you could go 4, 5, 6, 7, 8, 27, however many resistors you want. You would simply just add one to the next, to the next, to the next. So for this particular circuit, I've got a 1 ohm resistor, a 2 ohm resistor, and a 3 ohm resistor. And so for that particular one, I'm just going to go 1 plus 2 plus 3 ohms each for a total of 6 ohms. And so if the total resistance is 6 ohms and I wanted to find the current, again, I would go current equals V divided by R. I would go 12 volts divided by 6 ohms means that the current that passed through that particular circuit would be 2 amps. Okay? Now, for a parallel circuit, I really hate the way your book sets it up. It says, well, if you've got two resistors that are in parallel and they're both the same, okay, yeah, you're going to have some circuits where they're both the same. But the majority of them, you're not going to have just two, and they're not all going to be the same. So if there are two, then you simply divide, and they are the same, you simply divide whatever the same is by 2. So let's say you had two 4 ohm resistors. You'd take half of 4 and you'd have a 2 ohm resistance there. And it works by reason of this equation right here. If you want, try it out. 1 over 4 plus 1 over 4 would give me a total of 2 over 4. But then to find out what RT is, I flip it over. That's 4 over 2. 4 over 2 is 2. Okay. But for most parallel circuits, what you're going to run across is that they're not going to be the same, and there's going to be more than one of them. So, or more than two of them. So let's say I had the same resistors that I had here, but now it's a 1 ohm, a 2 ohm, and a 3 ohm, and it's in parallel. Got my 12-volt battery again. So what I want to do here is 1 over RT is equal to 1 over 1 plus 1 over 2 plus 1 over 3. Now, here's where it gets hard because you have to remember to your math. What do I need to do in order to add fractions? Oh my gosh, that was like 3 years ago. How do I add fractions? Well, the first thing you got to do is you got to find a common denominator. Common denominator between 1, 2, and 3 is 6. All three numbers will go into 6. So 6, 6, and 6. Then 1 times 6 is 6. 2 times what gives me 6? It's got to be 3. So 3 over 6. Again, 3 over 6 is a half. 6 over 6 is 1. What is 1/3 in terms of 6? How many times is 3 going to 6? 2 times. 2 times 1 is 2. So if I add those guys all together, again, I leave the bottom alone. Adding your fractions, leave the bottom alone, and add the top. So 6 plus 3 plus 2 is, what is that, 11? And so we have 11/6, but is that the answer? The answer is not 11/6 because we're looking for RT. Well, RT currently is 1 over RT here. So in order to find RT in the not 1 over form, I have to take this guy and flip it upside down. So RT is 6 over 11 ohms. And then what I could look at is a problem just like this. Well, what's the current if that's the case? Well, I'd take 12, divide it by 6/11. I don't know that off the top of my head, but you could certainly figure it out that point. I hope that's helpful. Again, the idea is just remember that you have to set it up in this particular way. 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3. And then just work your way through the math from there. It can get a little complicated, confusing if you don't remember your addition and subtraction of fractions. But I think most of you probably have that. The key thing to note here, again, with parallel circuits, is that 6/11 is going to be less than your smallest resistor. Our smallest resistor here was 1. So come quiz time. If you know parallel versus series circuits, oftentimes you can find the answer without actually having to do the math because hey, the answer's got to be smaller than the smallest one. And so 6/11 is smaller than 1. And then when you look at a series circuit, the answer is always bigger than the biggest one. So we've got to have an answer bigger than 3 here. And if we look here, total of 6 ohms, definitely bigger than 3. So series circuit, total resistance, always bigger than the biggest one. Parallel circuit, the total resistance is always smaller than the smallest one. So kind of a big difference there.